In this video, we are going to discuss the question paper 5-2 of the 9701 Chemistry A-Levels Chemistry of the examination series 2025 Feb March. So let's go ahead and solve question 1 in this video and question 2 in the next video. So here is question 1 and says brass is an alloy of copper and zinc and an experiment is completed to find out the percentage by mass of copper in a sample of brass. Now in the experiment, the sample of brass is reacted with an aqueous excess of concentrated nitric acid HNO3 and this forms a solution containing Cu2 plus ions. The amount of Cu2 plus ions formed is determined by titration. So what are we doing? We are taking brass in some quantity, reacting it with concentrated nitric acid to get copper into its ionic form, and then we are determining the amount of Cu2 plus, that is copper ions, with the help of titration. So here is the process, that is the method given, and the step 1 is weigh a glass beaker and record the mass. Step 2 is approximately 1 gram of the powdered brass in the beaker is taken and the record the mass of the beaker and the brass together and transfer the brass into the conical flask A, which contains excess concentrated nitric acid here, and then reweigh the glass beaker and record the mass. So here what are we doing is we are recording the empty mass of the empty beaker. Now in the step 5, what are we doing is add aqueous sodium carbonate dropwise to flask A until a precipitate of copper carbonate appears. Then add dilute ethanoic acid dropwise until the precipitate is fully dissolved. Now transfer all the contents of flask A to a 100 cm cube volumetric flask and make up to mark with distilled water, and this solution is a solution B. Okay, now transfer 10 cm cube of solution B into conical flask C. Add 10 cm cube of potassium iodide to flask C. Titrate the contents of flask C against 0.06. Now remember, this is the concentration of sodium thiosulfate we are taking using starch solution as an indicator. Repeat steps 7 to 9 until concordant results are obtained. So this is by titration we are determining the amount of Cu present in the brass. Now what's the first A sub question here? Both copper and zinc in brass reacts with concentrated nitric acid in step 3. So reaction 1 and reaction 2 is given, that zinc reacts, copper reacts. Now suggest why step 3 in the experiment should be completed in a fume cupboard. Now they are talking about step 3. Now what's step 3? Let's understand what is step 3. Step 3 is transfer the brass into conical flask which contains excess concentrated nitric acid. So in step 3 we are reacting brass with concentrated nitric acid, that is reaction 1 and reaction 2 are happening. Now this reaction 1 and reaction 2 should be carried out in fume cupboard, and the reason they are asking, that is the main question. So if you check at the reactions, you can see that the nitrate ions, that is the zinc nitrate and copper nitrate aqueous solutions are formed, nitrogen dioxide gas is formed and water is formed. Now if they are asking about fume cupboard, obviously we are talking about some gas which is harmful, and nitrogen dioxide gas produced is harmful, and that's why you can say is produced is a toxic. Actually the word toxic should be used. So nitrogen dioxide gas produced is toxic, and that's why we use a fume cupboard for this reaction to happen. Okay, this is the answer. Next sub question is explain why the glass beaker is reweighed in step 4. Now that I've already told you that we are measuring the mass of the empty glass beaker, reweighing in step 4. Why? To exactly find out the mass of brass transferred. So we can write that to calculate accurate mass of brass transferred transferred for the experiment, transferred for the experiment to the flask. So this is how we reweigh the beaker and subtract the mass to find out the exact mass of brass. The next up question is, name a suitable piece of apparatus to transfer 10 centimeter cube of solution B in step 7. Now in step 7, 8 and 9 we are carrying out titration, and for that we are transferring 10 centimeter cube of solution B in the conical flask. So the apparatus which we use is a volumetric pipette. Volumetric pipette, that's what we'll be using to weigh or measure exact volume of 10 centimeter cube. D is, identify the substance used to rinse the burette before step 9 is done for the first time. Now one thing we need to understand is that whenever you are performing a titration, the burette should be first rinsed with the distilled water, and then it should be rinsed with the solution which we are going to fill in the burette. So what is the solution which we are going to fill in the burette? Let's check in step 9. Titrate the contents of flask C against 0.06 mole per dm cube sodium thiosulfate. So sodium thiosulfate is the solution which we are going to fill in the burette. So we need to specify here that sodium thiosulfate is the solution, that is 0.06 mole per dm cube sodium thiosulfate solution, which is the solution with which we are going to rinse the burette. So fine, in step 9 this is done. E now, in step 9, 0.06 moles per dm cube sodium thiosulfate is used. This solution is prepared from 0.2 moles per dm cube sodium thiosulfate before the experiment. Now we need to understand that we have got 0.2 moles per dm cube concentration. We are going to dilute it to 0.06 moles per dm cube. Now describe how to make a 100 centimeter cube standard solution of 0.06 mole per dm cube sodium thiosulfate from 0.2 moles per dm cube of sodium thiosulfate solution. So what are we going to do is, we're diluting 0.2 moles per dm cube sodium thiosulfate to 0.06. So dilution is done, and that diluted solution we want as 100 centimeter cube. So obviously if we are using 100 centimeter cube, we need 100 centimeter cube of volumetric flask. So here it's given, give the name and the capacity of any apparatus you would use. So we need to specify 100 centimeter cube of volumetric flask is used, but then how many what volume of solution we will take from this solution of 0.2 to make it 0.6 this volume. Now for that we need to calculate that, and that calculation is done as follows, that 0.06 we want, right, and we want 100 centimeter cube of solution. So if we use 0.2 moles per dm cube, what is the volume we will use? That is something like N1 V1 equal to N2 V2, or you can say C1 C2 equal C1 C1 V1 equal to C2 V2. So concentration into volume is the formula, and if we want to find out volume, we're going to have V1 equal to C2 V2 divided by C1. That's the formula which we have used here. So if we find out this calculation, we get the volume as 30 centimeter cube. Now if 30 centimeter cube of the solution we are going to use, then say with the help of burette. Now I'm specifying burette, transfer 30 centimeter cube of 0.2 moles per dm cube of sodium thiosulfate solution to 100 centimeter cube of volumetric flask and add distilled water up to the mark and shake well. So this is how you're going to describe the process, that with the help of burette we are specifying the capacity also and the apparatus also. So transfer 30 centimeter cube of 0.2 moles per dm cube of sodium thiosulfate solution to 100 centimeter cube of volumetric flask. After that we are going to add distilled water up to the mark which is given in the volumetric flask, and then we are going to shake well. So this is how we describe the whole process. The next question, sub-question is, the measurements collected during step 1 to step 4 are shown in table 1.1. That's given here. That is mass of the beaker containing powder, brass, and then mass of the empty beaker after transferring the brass to the flask A. That is given here. Now determine the mass of the powdered brass added to conical flask A. So for that we are going to subtract 26.65 minus 25.65 grams, and so we get 1.00 gram of brass. We understand if we are using 2 decimal place, we need to give our answer to 2 decimal place, and that's why I have specified 1.00 gram of brass is transferred to the conical flask A. Okay, G is the volumes measured in each of the titrations are shown in table 1.2. So here is table 1.2, and the rough titration 1, titration 2 and titration 3 are given, and the final reading and the initial readings of each are given. So titers are, we need to subtract this two to get the titer volume. So for that we here have 20.80, then we have 20.30, next after subtraction we have 20.55, and then we have 20.40. So this is the volume which we get after subtraction of these two readings. So here we have completed the table 1.2, and then calculate the suitable mean titer to use in the calculation. Now we need to understand that we need to use the concordant readings, that is the readings which are very close. Now we can see that from these 3 readings we can see that 2.30 and 2.40 are the 2 readings which are close, that is with the only difference of 0.100. So those are the readings we can consider. The readings which are more than this difference we cannot consider for the calculation. So for calculation mean, we are going to take the average or the mean of these 2 reading, and then we use that titration, that is titer, for the further calculation, and that is 20.35 mean titer from these 2 readings. Okay, now the third one is calculate the percentage error in the titer in the titration 3 and show your working. Now how do we find out the percentage error? So what is the maximum error in a burette reading is 0.05. Now why? Because we have the minimum reading in the burette is 0.1. So 0.05 is something which our burette cannot read for us. So maximum error in a burette reading is 0.05, but if we are using the burette reading twice, why? Because we use initial reading and final reading from the burette. So we need to multiply 0.05 by 2 because we are using burette twice for a single reading, right? And they say calculate the percentage error for the titration 3. Now titration 3 reading is 20.40. So that's what we are going to divide it by. So 20.40 we will multiply by 100. That's how we calculate the percentage error. Understand, we are multiplying the maximum error by 2 because we are using burette twice for a single reading. The titration reading 3 is 20.40, so we'll divide it by it and then multiply by 100. So our percentage error is 0.490 to 3 significant figures. So this is the maximum percentage error in our single burette reading of titration 3. Let's see what's the next sub question here. The next sub question here, H, is in step 8, copper ions react with the iodide ions and the ionic equation for the reaction is shown. So here is the reaction 3, copper ions reacting with the iodide to form copper iodide and iodine, and in step 9 we titrate with the help of starch indicators. So here sodium thiosulfate is reacted with the iodine formed in reaction 3 and we get the titration reading. So the first sub question is, using a second sample of brass, another student determined the mean titer to be 17.35 centimeter cube for the same moles per dm cube, that is concentration of sodium thiosulfate. So calculate the amount in moles of this sodium thiosulfate in the student's mean titer. So if we are talking about moles, we need to have concentration multiplied by volume, and that is 0.0600 multiplied by 17.35 divided by 1000. Why? Because we are changing 17.35 centimeter cube to dm cube. So conversion we need to divide by 1000, and so we get the answer of moles in 1.04 into 10 power minus 3. So this is the amount of moles, 0.41. Why? Because to 3 decimal places here. Okay, in the second part, if we are writing to 3 significant figures, we can write to 1.04 also, that is fine. Use the equation of reaction 4 and use your answer to H1 to determine the amount in moles of iodine that reacted with sodium thiosulfate. Now reaction 4 and your answer. So reaction 4, if we check, if we want iodine and sodium thiosulfate, if we are calculating, the moles of iodine are half the moles of sodium thiosulfate, because here the ratio was 1:2. So compared to sodium thiosulfate, iodine is half. So if we want to calculate the moles of iodine, we need to divide the moles of sodium thiosulfate by 2, that is 1.041 into 10 power minus 3 divided by 2. And if we divide it by 2, we get the answer as 5.21 into 10 power minus 4 moles. Right? The third part is, use the equation for reaction 3 and use your answer to H2 to determine the amount in moles of copper ions in 10 centimeter cube of solution B. Now, if we are talking about reaction 3, if we check the moles of iodine and the copper ions, again it is 2:1 ratio, right? So again we need to multiply it by 2, that is the moles of copper ions has to be the moles multiplied by the moles of iodine multiplied by 2. So if we again multiply it by 2, we get the same answer, that is 1.041 into 10 power minus 3. So that's the answer we get. In this case, we can write even 2 because we multiply 5.21 into 10 power. So we get 0.42 also can be written. So fourth is, calculate the mass of copper present in the second sample of powdered brass. Now that is done when we need to understand that here we had taken only 10 centimeter cube of the solution B. Now the whole of solution was 100 centimeter cube in our volumetric flask. So we need to find out the moles in 100 centimeter cube from this mole. So our moles will be 10 times greater right? So the moles of copper ions in total is equal to 1.042 into 10 power minus 3 multiplied by 10. So these are the moles of copper ions, and if you want to find out the mass, then mass is moles multiplied by the mR. So here we can directly add 1.041 or 042 multiply by 10 power minus 3 multiply by 10 and multiply by 63.5, which is the relative atomic mass of copper, and our answer is 0.661 grams of copper. Okay, the mass of the second sample of powdered brass was 1.05 gram. Calculate the percentage by mass of copper in the second sample of powdered brass. Give your answer to three significant figures. So if we have the mass of copper is 0.661 gram out of the total mass of brass, that is 1.05, and then multiply it by 100, so that we get the percentage in three significant figures. So percentage in three significant figures is 62.9% here, and that is the percentage by mass of copper in the brass, which is 1.05 gram. So here we have taken 1.05 gram. The mass of the copper which was found in the brass was 0.661. So divide it and multiply by 100 to get the percentage. So here our question 1 ends, and in the next video we will be solving question 2.